Tonight we'll be looking at molar volume of gases, which is called the gaseous molecular volume, GMV, molar volume of gases. Now, for the molar volume of gases, remember we are still on the gas law. The topic that ended the gas law is called the Graham's law of diffusion. So, but we are going to check the two together this night. So, but the first subtopic we are going to check here this night is molar volume of gases. Now, the molar volume of gases is also known as what is called gaseous molecular volume at STP. Take note, at STP. So STP represents the standard temperature and pressure. So now we are going to start now. When we are talking about gaseous molar volume, now in this place we are referring to a mole of a gas. Are you with me now? A mole of a gas at what's called has a volume of 22.4 dm cube at STP. How do I mean? A mole of a gas has a volume of 22.4 dm cube at STP. So what does this mean? This volume of 1 mole of a gas is known as the what? As the molar volume of gas. Are you with me now? Molar volume of what? Of gas. So the value is also constant as well. Now, that is to tell you that the weight 6.02 times 10 raised to power 23 represents 1 mole of any given what's called matter. The same thing that the 22.4 dm cube also represents 1 mole of any given gas. Quote me well. 1 mole of any given gas. Now, in that place, that is to tell you that 22.4 dm cube, or let's say 1 mole of 22.4 dm cube contains 1 mole of what? Of chlorine gas, 1 mole of oxygen gas, 1 mole of H2S gas, 1 mole of hydrochloric gas, 1 mole of CO gas, 1 mole of CO2 gas, 1 mole of NO gas, 1 mole of NO2 gas, 1 mole of hydrogen gas, and so on. So that is to tell you that 1 mole of what? 1 mole of any given gas at STP is equal to 22.4 dm cube. 22.4 dm cube. So take note of that. Don't use that one to eat a Google and a pal. Very, very important. So let us look at how question can come on them and how to attack question on them. Let's go there. Now, we're given the example 1 from the question. The example 1 from this question states that what is the volume of 8.0 gram of oxygen at STP? What is the volume of 8.0 gram of oxygen at STP? Now, let's check it out and see how it goes. Now, based on what we have here, all you need to do is to calculate the mole. Remember, we are dealing with mole as well. So, that means mole is equal to mass over what? Over molar mass. The mole is given to be what's called 8.0 gram. The mass. But the molar mass of oxygen gas, O2, is what? Is 16 times 2. 8.0. Now, for what we have here now, 8 over what? Over 32. That is what we are going to have there. You now multiply by the what? By the GMV, which is what? 22.4. So let's do that. What are we going to have on our calculator? Now we have 8 times 22.4 divided by 32. Our final answer there will give us what? 5.6 dm cube. So that is to tell you that the volume of oxygen gas now at STP is what? Is 5.6 dm cube. Take note of that one. Now, based on the question, let's check the question 2. What volume of oxygen at STP will be obtained when 24.5 gram of potassium triisochlorate 5 crystal are heated? Now, O is 16, K is 39, Cl is 35.5. Now, the first thing you need on this problem is what is called the equation for the reaction. So they said KClO3 were heated. This sign represents heat. So were heated to give rise to KCl plus what? Plus O2 gas. Now check the equation. Is it balanced? No, balance this with 3, with 2, with 2. The equation is balanced. Now for this balanced equation, now here we go. From the question, you were given that 24.5 gram, right? So the mass is given to be what? 24.5 gram. Now the second thing is the molar mass. Molar mass of KClO3. So for the 1 mole of KClO3, altogether we give you 122.5. Let's confirm that. So for this one, you now multiply by 2. Where do we see the 2? The 2 that we have here. And when you multiply everything here by 2, you are going to have that is 2, 4, 5. When you multiply everything by 2, you are going to have 2, 4, 5. Now for this 2, 4, 5, you now proceed with what you are given. So remember, your mole is equal to what? Your mass over the molar mass. So your mass now is given to be 24.5 over the molar mass is 245. You now multiply by how many moles of oxygen are present here. How many moles of oxygen do we have here presently? So check here, we have 3. And for oxygen, remember at STP, the volume of oxygen for 1 mole of oxygen as STP is what? Is 22.4. So for this 3, we are going to say 3 times 22.4 over 1. Take note, this one itself will give you 0.1. Multiply by 3 times 22.4. Now, at the end of the day, what are we going to have? From our solvings, we are going to have 6.72 dm cube of oxygen. That is what we are going to have there. That will be the answer to the question. I can still recap it. The moles of oxygen here is 3. Take note. And 1 mole of any given gas as STP is equal to what? 22.4. So that is why we have 22.4 here. Multiply by the 3. This one will give you 0.1. Multiply all together, will give you 6.72. Now take note of that as well. For more questions on the one that we have treated today, you can check your Johnson Publisher Jam Pass question. So you use it as your self-assessment questions. So we have 1995 question 3 and the rest of them. So it's what you can go through them. Then you solve questions on them. You send your answer to us as well. So the next topic we'll be checking is what is called the vapor density. The vapor density. So when we are talking about vapor density, so vapor density of a gas is expressed as the number of times a given volume of gas is as heavy as the same volume of hydrogen at a particular temperature and pressure. So take note of the definition. Now, vapor density can easily be expressed in this form, that Vd is equal to 1 multiplied by molar mass divided by 2. Why do we have this expression? Vapor density, just to cut the story short, is just like half of molar mass. Yes, vapor density is just like half of molar mass. There is nothing for you to know there, nothing. Now, let us take a look at this example now. If a question asks you that calculate the vapor density of sulfur 4 oxide. Now, that is what the question asks you to calculate. If you want to calculate that, sulfur itself is 32. Oxygen itself is 16. Now, and for sulfur 4 oxide, the formula is what? SO2. What do you need to do? 32 plus 16 times 2. All together, we give you what? We give you 64, if I'm not wrong. 64. So that represents the what? The molar mass. Now, the questioner says calculate the what? The vapor density. So for the vapor density now, we are going to say that Vd is equal to molar mass divided by what? By 2. So we are going to say that 64 divided by 2 will give you what? 32. That is the answer to the question as given from the place. So no much on why calculating vapor density, and they normally ask vapor density. So they can arrange different gases and ask that which gas will diffuse at a fast rate. The gas with the lowest vapor density will diffuse at a fast rate. Take note of that one. So that is what we have there on that.